All right. So just like everything else in part five, um, my original work, right, focuses on how to do these questions um, by hand using a calculator and I mean by a calculator, a graphing calculator, or a scientific calculator. Now I'm going to show you how you could do these using online calculators, just like I did with the binomial. So there's definitely easier ways to find normal probabilities and values from the normal distribution than using a clunky calculator with technology from the late 90s. So anyways, if you're reading through exercise 3 in our notes, I'm a lazy student and I'm sort of skimming until I get to the last sentence where I see some really important words. The most important word, of course, here being approximately normal. That tells me that I'm going to probably be using one of those normal calculators. I'm in this land where I'm going to draw a curve. They've given me a mean of 49.4 and a standard deviation of 3. So if you're going to be really lazy about it, which I tend to be, I almost don't need any more of the question. I've gotten everything I need right here. As I read forward, we can see we have a suspect for a thing, and they have a score of 5790. This appears to maybe be an observation from my normal distribution. We tend to use X to talk about random variables that come from a normal distribution, just like we use X to do random variables that came from a binomial. And we are looking for the probability that a person scores that or higher. So we've been told we're looking for a probability, which means I want an area under the curve. If we were using the graphing calculator, we'd be like, all right, I need normal CDF, and I could draw a cute little drawing. So on this week's worksheet, I'm going to ask you guys to draw a picture for every single normal problem. There are 3 things that I really want to see in any normal drawing. 1, I want to see that you've put the mean in the right place. So draw a line and put down that average or mean skin response score of 49.4. I want to see that we know where the actual cutoff value that we're looking for, this probability, it starts here at 57.9. It is important that you put this on the correct side of the curve. 57.9 is larger than 49.4, so it should be to the right. And then that you have the shading in the right place. So we want this value or higher. So we'd want this shading, and I like to put a little question mark to show that's what I'm looking for, this area under the curve. If we were using probability notation, which I'm not a huge fan of because I find from a lot of students it just kind of confuses things, but if you enjoyed it from the binomial section, we want to show that our x is greater than or equal to, it says or higher, than 57.9. So that's what we're looking for. Now, if you go to help from a tutor, they're probably going to have you convert this to a z-score and then use the standard normal table to look this up. That is old school, antiquated ways to calculate normal probabilities. We are not going to do that. If you do that on the test, I'm going to judge you and I'm going to assume somebody else took the test for you. And you'll probably get called in to explain how exactly you found that probability. So what you should be doing instead is coming to a calculator. So I added some calculators to our, oops, that's not what I wanted to do, to our course resources. We have 2 different calculators down here, a normal calculator and inverse normal. If you want an area under the curve, we're going to be using the normal calculator shortcut. And you can see here, it does default to a standard normal, a mean of 0 and a standard deviation of 1, but you can change this up. You can change this to that 49.4, and I've already forgotten what my standard deviation was. Was it just straight up 3? Interesting. Straight up 3. And then we could say that, oh, we wanted above, again, I've already forgotten, 57.9. So 57.9. We do need to make sure that we enter that and that we choose above and then press recalculate. So there's our probability, 0.0023. So this probability is equal to 0.0023. So in terms of work on the exam or on the worksheet, since you don't have to find a z-score and do a lot of work, the work is going to be mostly drawing this picture, right? Having all those pieces I talked about, And then I would say in terms of my work, just tell me I use the normal calculator. And then above. So what did I put into that normal calculator? Above. There's my supporting work. I'm done. I'm awesome. You could also, of course, use StatCrunch for this. So just to show you the StatCrunch version, in StatCrunch, you could go again back to the stat area, back to calculator, and choose normal. And you can see it says right now we've got a mean of 49.4, standard deviation of 3, and it's a little more annoying because we have to actually have the notation. You'll note here that it doesn't have a less than or a greater than because technically when we're dealing with continuous distributions, the probability of any one outcome is just 0. So we were looking at 57.9 and it just says 0.0023 and it gives us a drawing. So both of these calculators give you a drawing, so you could use that as sort of a heads up for that drawing on your page. So that's how we could do those. If you need a between, you can choose between instead of a greater than or less than. And then this one also will let you see, if you wanted to, all of the basically the empirical rule. 1 standard deviation, 2 standard deviation, 3 standard deviations away. So in this case, you can see this value of 57.9 is right before 3 standard deviations away from the mean. So you could actually see sort of where that z-score would have fallen. So the other side of this is the inverse question. This next question, we see suspects with skin response scores in the upper 3%. As soon as I see a percentage, I'm thinking my alarm bells are going off in a normal question that this is probably an inverse problem. And then find the minimum score. So that's the little like nail in the coffin that says, okay, we're looking for a score. I'm not looking for the area under the curve. That was what was given to me. Again, you have a drawing here, 49.4. We do not know what our cutoff is. We have to use this keyword of upper, which tells me I'm looking for that 3% on the right. So I'm going to shade what it looks like 3% to me. And I'm going to say, I want to find what that score is. So I like to make sure that that x-axis is just scores and that the percents are floating above. It kind of makes me a little crazy when students write their percents down on that axis as if they're skin response scores when they're not. So we need an inverse. Again, if you wanted to do notation on this one, it's a big pain in the butt. We're trying to find some x such that, some little x such that this is equal to 0.03. And that means nothing to a lot of students, but this drawing means a whole lot. I already know that the value is greater than 49.4, and I've got some information. So I'm going to go ahead first. I'm going to use that inverse calculator here, because I don't know where it is in StatCrunch. I'm going to have to figure that one out. So the inverse calculator gives areas under the normal distribution is what we need. You're going to type in your area as a decimal, so 0.03 for that 3%. I'm going to throw back in my mean, 49.4, and my standard deviation of 3. And then again, you're going to choose above, below, between, or outside. So if it was a below, we'd be down here. Between would give us a middle percentage, and outside would give us a percent in the tails. Here we want an above, so our answer is just going to be 55.042. So this question mark here is 55.042, and there were no units, so typically we'd want to throw units back on top of this thing. My child is home, so there's now chaos. But let's see if we can figure out how to do this if we want to do this as an inverse calculator. So the StatCrunch doesn't have an inverse calculator that's separate. I believe I can just type in here the probability I want and whether it's above or below, and then I can press compute. So that's that thing that's kind of nice. I just have to give it whatever I want, and I'll have to go to a different calculator. So I still get that 55.042 using StatCrunch's built-in calculator. That was the answer to this problem.